Hey everyone, on this lesson we are going to study the IP assignment, that is, how are IP addresses assigned. So an IP address, essentially identifies an interface connected to a network that sends and receives datagrams. So this IP address is mapped to layer 3 or higher equipment interface. For instance, the host and the router can have IP addresses, however the switch and the hub cannot. We are going to study switch and hubs deep and later in the future. So some important aspects is that the IP addresses with the same net ID belong to the same network, okay, very important. The host ID identifies a network interface net ID. And finally, all the IP addresses must be different. So now let's study an example. Here we have two networks, okay? We have this first network, we have three interfaces, and then we have this second network. So they are separated by these routers. We can see these three are interfaces, and also these three are interfaces. And we also have three interfaces, and inside this network too, what we have here is something that is called a switch. And a switch forwards data between devices, unlike routers, which forward data between networks. So, the networks and the interfaces must have their IP address identified. So in this case, we have to identify these two networks. So here, for instance, let's define the masks with 24 bits. So we will have here the slash 24 once in a row for the network 1 and also for the network 2. Keep in mind that in principle, each network can have any mask. Important, the selection of this mask depends on the size of the network, right? The number of interfaces with an IP address inside this network. So now let's assign the net ID, the network identifier, to each of these networks. So remember, since we have a mask of 24 bits, right, as we know here, then we will need to select here 3 decimal values for the net ID. Right, so if we have 24 bits in one, it means that each decimal place is 8 digits. So here, if we divide 24 by 8, we have the number of digits that we will have on the net ID, which is 3, right? So now the net ID, the network identifier, will be, for instance, for the network 1, 10, 0, and 1, and for the network 2, 10, 0, and 2. So this notation is correct because, on one way, they are different, and on the second way, we select 3 decimal places for each of them, right? And now we need to here assign the host IDs for each computer, right? For each PC, and also for the interfaces, right? Here we have an interface that goes from the network 1 to the router, and also we have this interface that goes from the network 2 to the router, and also lives from the router to the network 2, and also lives from the router to the network 1, right? In this case, it is the same if it comes to the router or if it leaves the router. What we are interested is here which side this is the interface. So we will have two interfaces for the router, right? So we assign the host IDs. So keep in mind, let's start with the network 1. Let's begin with this network 1. So we know that the net ID of the network 1 is 10.0.1. Therefore, all of the hosts, all of the applications and the PCs, right, inside this network 1, they must have the net ID 10.0.1, and this is true, 10.0.1, 10.0.1, and 10.0.1. So the only thing that changes is the last number that identifies the host ID. So we will have 2, here we have 3, and here we have 4, right? And now we came here to the router interface. So again, since this interface belongs to the network 1, and this is very important, if I have a network connected to a router, the interface that connects the router with these networks need to have, this interface needs to have the same net ID as the network. That's why here we have the net ID 10.0.1, and here this is the interface identifier, the host ID. This is one for this case, right? Very well. Now we came to the network 2 again. On this network 2, what is happening? Since we have the net ID is 10.0.2, all of these interfaces, all of the applications must have 10.0.2. That's why we have here all of them 10.0.2, 10.0.2, 10.0.2. Right? The only thing that changes here between these computers is the host ID. So for this case, for this computer, we selected 10. For instance, we can have here any value from 0. In this case, we will learn why 0 we can't. Okay, we are going to learn why 0 is not possible. But we can have from 1 to 255. This number that we see here at the end, the last digit, this 10, okay, can be any number between 1 and 255. And in fact, we are also going to learn that the last one, okay, because commonly you have from 0 to 255, and also 255 is not possible for a host ID. So again, we are going to repeat again, very important, this last number here, 10, instead of being from 0 to 255, which is basically the digit representation, right, the range representation with 8 bits, instead we can only go from 1 to 254, and we here remove the 0 and we remove this 255. We are going to learn why on this same lesson, okay, in some minutes, why we can select all zeros or all ones, okay, in this last decimal place. So we can have here 8 zeros in binary, okay, to represent this last value, and we can also, okay, we can have this last decimal value to be all ones, so 8 bits in one in binary. Okay, we are going to learn why in some moments. So here we'll select the host ID 2, the host ID 20, very easy, and then finally the interface that connects this router. Since this router is connected, this interface, to this network, this router's interface needs to have the same net ID. That's why we have here 1002. And then finally the interface, the host ID identifier is 1. Now very important that here you remember that a switch, okay, a switch and a hub do not have, okay, the IP address. Why? Well, because they are not layer 3 or higher equipment interfaces. Okay, the host and the router are, but the switch and hub no. That's why if we have a switch here, we don't assign any IP address to this switch. Now let's study why we can use in the host ID, okay, all zeros or all ones in binary. Okay, essentially, why can we have something like this, where the host ID is 0, so we have all zeros in the host ID, and also we can have something like this, where we select all ones in binary to represent this number. So keep in mind, if you write 8 ones in binary, this is the number 255 in decimal. So why can't we have something like this, okay, where we have all zeros, and also something like this, where we have all ones? Well, there's a reason for this. And the reason is that they have another meaning. If we use here this host ID to be all zeros and this host ID to be all ones, this means that they have another meaning. Keep in mind that we are now studying the example where we have a net ID of 24 bits, so we have a mask of /24, but this here is applicable to any example, to any, okay, host ID that we can have. If we had here a mask of 16 and we have the last 2 decimal values to be the host ID, then the same idea is defined. If we have here only 2 decimal places for the host ID, okay, so we only have now, we have 16 bits for the net ID and also 16 bits for the host ID, the same here. We can use something like this, 00, where all of the host ID, now 16 bits, is 0, and we can also not have something like this, okay, we mustn't have something like this, where all of the 16 bits of the host ID in binary are all 1. This basically means that we have something like this in decimal representation. We can have that. Why? Well, because they have another meaning. So now, coming back to the example of the network 1 and 2, where we have and we use a mask of 24, if we here use the host ID with all of the bits set to 0, this identifies the network address. Okay, so when we type now 1001, remember that this is the net ID that we selected for the network 1, 1001. So if we type 1001 and then the host ID, all of the bits to be 0, we are representing the network address of the network 1. In the same way, okay, in the network 2 that we selected this net ID, 1002, if we type 1002 and all of the bits of the host ID to be 0, okay, and with the mask also, commonly we denote the mask as well, we are representing the network address of the network 2. So networks also have an address. So here we are only defining the net ID, but this is not an address. This is a sub address of the whole network address. So the net ID is this one. However, the full network address of the network 1 and the network 2 is these two IP addresses that we see here. Okay, 10.0.1.0, all of the bits of the host ID to be 0/24, network address of the network 1, and then 10.0.2 net ID, and then the host ID, all of them 0/24, the network address of the network 2. Remember that this 24 represents how many bits, okay, we have on the mask for representing the net ID. In this case, the first 3 digits, 24 bits, right, represent the network ID, and the remaining ones, the last digit, the last 8 bits, represent the host ID. So we already know the case, the host ID with all the bits to 0 identifies the network address, and now, what if we now use the host ID with all of the bits set to 1? Well, we also, okay, have a special meaning for this, and this is that this identifies the broadcast address. So whenever we have this address here, we allow all of the host IDs are 1, essentially, right? All of the bits of the host ID are 1. Essentially, this is the same as having 255 in the case that we have here, because now this separation is only with 8 bits, okay? So we have that this is the broadcast address of network 1. In the same way here, we have all of the bits of the host ID to be 1. So this is the broadcast address of the network 2. Remember that we already studied this broadcast datagram. This is a type of datagram that from a source host, when we send a datagram, or basically broadcast datagram, we send for all of the destinations in the same network that the source host is sending. So essentially the source host network. So if we have here this complex networking, if we send a broadcast datagram, this datagram, and we send it from here, this datagram will only arrive to this PC, and this PC. They are the only ones that are connected to this network, right? So essentially, if we send a datagram with destination, the broadcast address, this datagram, okay, imagine that we send it from this host, is going to arrive to all of the destinations of this same network. So all of the interfaces that are connected to the network 1, right? So we are going to send to this PC in here, to this one, and finally also to the interface of this router. All of these interfaces are going to here receive this broadcast datagram. So a single datagram is going to be sent, but it is received on all the interfaces of the same source network. Very important, okay, very important notion. It is not possible to send a broadcast datagram to other networks, okay? Broadcast datagram is by definition only the network that we are sending from the source host. Now, for instance, just imagine that we try to send from this host that has this IP address 10.0.1.2, and it is connected to the network 1 because we know that it starts with 10.0.1. So now we send a datagram with destination the broadcast address of the network 2. Keep in mind that this broadcast address is the net ID of the network 2, which is 10.0.2, and then all of the bits of the host ID to be 1. So in 8 bits, we have this decimal value, 255. So if we send this datagram with the destination the broadcast address of the network 2, what is going to happen is that no one is going to read this datagram, right? No one is going to read this datagram. This datagram is going to be discarded because it is impossible to send a broadcast address, okay, to send a broadcast datagram to a network that is not the source network, right? It is not possible to send a broadcast datagram to other networks, only the network that we are. Very well, so with this we end this lesson on the IP assignment. We remember the student that you can download all of this documentation on the downloadable documents of this lesson.